Question 35, 7 marks. Unknown samples of 3 carboxylic acids labeled X, Y, and Z are analyzed to determine their identities. Both Y and Z react rapidly with bromine in the absence of UV light, but X does not. A 0.1 gram sample of Y reacts with the same amount of bromine as a 0.2 gram sample of Z. Separate 0.1 gram samples of XYZ are titrated with 0.0617 moles per liter sodium hydroxide solution. The theta volumes are shown. Both Y and Z can undergo hydration reactions in the presence of a suitable catalyst. 2 products are possible for the hydration of Y, but only 1 product is possible with Z. Identify which structures 1, 2, and 3 in the table are acids X, Y, and Z. Justify your answer with reference to the information provided. Okay, the way you approach this question in order to get 7 marks is to address all the 3 dot points and then categorize them into structure 1, 2, and 3. So I think the best way to begin is to construct 2 tables that compares the information for X, Y, Z and structures 1, 2, and 3. Please pause the video to look at the marking criteria to understand how you can get 7 marks. Let's look at bromination. X does not react with bromine. Only Y and Z react with bromine. So that means X is saturated. It doesn't have an alkene or an alkyne. It is only a carbon-carbon single bond. Number 2, the same amount comment. We'll come back to this. And number 3, hydration products. It is typically done with H2O and H2SO4, which provides you with an alcohol. So we are going from a unsaturated alkene to a saturated alcohol, and that is the transformation. Let's look at structure 1 to begin with, and then we'll finish up with structure 3. So structure 1 is 2-propenoic acid. So the priority number goes 1, 2, and 3. Now we're going to transform that to an alcohol. And in order to do that, we use the conditions of H2O in H2SO4. There's an alkene bond between C2 and C3. So do we put the hydrogen here or do we put the hydrogen here? And similarly, we can also ask, do we put the hydroxide here or do we put the hydroxide here? Because there are 2 possibilities in the one structure. Now it turns out to be when we're adding hydrogen hydroxide to the alkene portion of the structure, we are going to get a major product and a minor product. Let's draw the major product first. This is 2-hydroxypropanoic acid. In this major product, we put the hydrogen to this carbon and we put the hydroxy in carbon number 2. Now similarly, we can do something else to the structure which will become the minor product. So in this minor product, we are going to be adding the hydrogen right there, and we're going to be adding the hydroxide right there. So that's the structure 1 with hydration. Now we know from the information provided in the question that only one of them undergoes hydration with 2 products, and that particular example is structure 1 is Y. So that leaves structure 3 to be Z. Structure Z has a mirror image. We are only going to get 1 product because they are equivalent. We have confirmed the identity of these structures by using the information of bromination and hydration. So now we are going to address point number 2 and point number 4 to further show evidence of the structure that we've assigned to 1, 2, and 3. We know that 0.100 gram of structure Y reacted with the same amount of bromine as 0.2 grams of structure Z. So if we compare the moles of these 2 molecules, we get the same mole, 1.38 times 10 to the negative 3. when we review the equation mass equals mole times molar mass, since the mole is the same, we can look at the mass. And structure Z is twice the amount of mass to structure Y. We can then conclude the molar mass of Z is double the molar mass of Y. So from this evidence, we can confirm that structure 3 is a diprotic acid and structure 1 is a monoprotic carboxylic acid. Point number 4 is to do with titration against 0.0612 moles per liter sodium hydroxide. And each of them was given the volume of sodium hydroxide to reach equivalence point. Since each of the carboxylic acid was 0.1 grams, and knowing the molar mass, we can work out the mole of the individual acids. The mole of sodium hydroxide against the Y acid is 1.38 times 10 to the negative 3 mole. The mole of sodium hydroxide against the X acid is 1.349 times 10 to the negative 3 mole. And then the mole of sodium hydroxide against the Z acid is 1.38 times 10 to the negative 3 mole. So if we now compare the carboxylic acid and sodium hydroxide, the first one is a 1:1 ratio, meaning that the Y acid is monoprotic. Similarly, the X acid is also a 1:1 ratio, so the X acid is monoprotic. Z acid is 1:2, twice the amount of mole of the sodium hydroxide to reach equivalence point with 1 mole of the acid, which means that the Z acid is diprotic. Let's look at the sample answer. X does not undergo an addition reaction with bromine or a hydration reaction, so it does not possess a double bond. Thus, the only structure that can be X is structure 2. Y and Z2 contain at least one double bond because of the addition and hydration reactions. As 0.100 gram of Y reacts with the same amount of bromine as 0.200 gram of Z, Z must have a molar mass that is double the molar mass of Y. Only one product is formed from the hydration of Z, so Z must be symmetrical around the double bond, and Y is not symmetrical. The equal volumes of Y and Z in the titration is a result of Z having doubled the molar mass and Y and being a diprotic acid. Thus, structure 1 is Y and structure 3 is Z. Thank you for watching. Please follow and subscribe to this channel for more quality content. I'll see you next time.